Hello friends, I am Kishore and welcome to Chennai Robotics Platform's Tech Talk featuring Dexbot 2019. So for the first three videos we were featuring Electrofocus 2019 and this week we'll be featuring on Dexbot 2019. So now Dexbot 2019 is the annual symposium of the MIT Robotics Association of Madras Institute of Technology, where we will be taking workshops on Arduino, on image processing, on ethical hacking, on Internet of Things, and another Arduino workshop where we'll be working on line follower and all those stuff. And for registering to the workshops and events, visit www.dexbot.mitindia.edu. Okay. So for the first 3 weeks, we saw about embedded systems, Internet of Things, and computer vision. So now the next topic which we will be seeing about is deep learning, and we will be splitting it into two videos. In this video, we will be speaking about the neural networks, and the next week we will be speaking about convolutional neural networks. Okay, so now let's get started with neural networks. Okay, so before moving on to neural networks, let us see about deep learning. So deep learning is a different approach which we use for finding solution to problems. So for almost 100 years we were using programming approach to find solution to problems, but deep learning is totally different from programming. So now programming gives us a very sharp answer. Now if I give a question like 1 plus 2, it will give us the value 3. But deep learning will not give us 3. Instead, it will give something like 2.8 or 3.2, somewhere close to 3. So you might be thinking, deep learning is not accurate, so why should we use this instead of programming? But the thing is, 1 plus 2 is not the kind of problems which we feed to deep learning. What we will be doing is, we will be using deep learning to predict a person if a photo is given. It's like, it will see this photo which you are seeing now, and it will tell now Kishore is present in this image. Now if I show this, it will tell a whiteboard is present in this image. Now we can't do such things using typical programming. That's why we will be using deep learning. Now there are many applications of deep learning. So the first one is regression or prediction. Okay. Now if I want to calculate the stock market values that will be present at 6 p.m. today. So now this video is being taken at 2:30 p.m. So if I want to predict what the stock market's value will be at 6 p.m., we can do something called as regression or prediction. And we can even use regression or prediction for something like predicting the cost of a house which is present in a particular locality and it is having a 1000 square feet area and all those things. So if we feed such kind of data to a deep learning model, it will give us an approximate prediction of what the rate of the house will be. And the next thing which we can be using deep learning is for classification. Now if I show a small face, now you saw a video before this clipping, right? That was classification. So now whether I am smiling, whether I am happy, or whether I am angry, or whether I am surprised, so that is classification. So it can tell whether a particular object belongs to this class or another class. So now there are two kinds of classification. One is called as two-class classification and another one is multi-class classification. In two-class we have only two classes. So yes or no. So now let's take a small two-class problem where I am smiling or not. If I am smiling, it will give an answer called as yes. So if I am not smiling, it will tell no. So there are only two classes. But in multi-class predictions, there are more than two classes: smiling, angry, surprised, and we can even add things like sad and all. We can add more than two classes. That's what comes under multi-class classification. Okay, the next application of deep learning is generation. So deep learning can be used to create art. It can be used to create music. It can be used to create even videos of movies. It can be used to even create movies. That's what deep learning is headed towards. And the next thing which can be done using deep learning is object detection. Now I'll show an image and the deep learning model will tell what is present in that image and where it is present in that image. So that is object detection, and we will see about that in future videos. Okay. So now let's move on to neural networks. Okay, now to explain neural networks, let us take two problems. The first one is, now I am participating in a competition. No, I am organizing a competition, and I have to select only people who are having an age greater than 18. So if the age falls greater than 18, they will be selected, and if not, they won't be selected. So for that, in conventional programming, use something like this. If age is greater than 18, then it is true, otherwise it is false. So that is how we solve that problem using conventional programming. Okay, now another problem we have is the body mass index of the person should be greater than 18. So now the age is of no consideration. Here the body mass index was of no consideration, but here the age is of no consideration. Okay, so if the BMI is greater than 18, so you will be selected, otherwise you won't be selected. So now I am using two kind of methods to select people. So in the conventional programming, you will be using, if BMI is greater than 18, it is true, otherwise it is false. Okay, but in neural networks, we will be using functions. So we will be having something like this in neural networks, a line, and here for this problem we will be having a line like this. So the equation of this line is x minus 18 equal to 0, and for this the equation is y minus 18 is equal to 0. Okay, so x, now this will be implemented using a neural network, even this also. Okay, so how we do that is, now we are having two inputs, age as well as BMI. So here BMI was of no consideration. So the coefficient of y was 0, and the coefficient, this is x and this is y. So the coefficient of x is 1. So 1x plus 0y minus 18 into 1 is equal to 0. So now this is the equation which we should achieve. And how that is done is, we have x here, we have y here, and we have our bias value 1 here, and now they will be multiplied with minus 18, 0, 1, and they will fall here. Okay, so we do addition of all these three. So now the coefficients of x are called as weights, w, and the x, y and themselves are called as capital X. So now this is one vector, w1, w2 and bias, sorry, w1 and w2, and the inputs are x and y, and then we have our bias value which is added to them. Okay, so now it can be written something like this. So now this neuron will be doing this. Okay, so that is one thing. So we are doing matrix multiplication for deep learning, so keep that in mind. Okay, and the next thing which we will be doing is this problem, where we will come up with this. Okay, here it is x1, y0, 1 minus 18, and for here it is y1, x0, 1 minus 18. Okay, so now this will be achieved using neural networks. So the neural network will give us this line, So if I give an age which is lesser than 18 now I will give x as 17, and y, it can be anything, it doesn't matter, so it won't be counted. So and then if I have 17 minus 18, it will give me a negative value. If I give an age greater than 18, this will give me a positive value. So similarly here, if the BMI is greater than 18, it will give me a positive value, and anything lesser than 18 will give me a negative value. And 18 itself will give me 0, and it will be grouped together with this. 0 will also be grouped together with this. So how do we achieve this line? The neural network will predict this line. So initially, the neural network will start with a random line, and the line will correct itself to achieve the perfect line. So initially, let's say the neural network has something like this, x plus y minus 18 is equal to 0. So that is this line. So we have to tilt this line to bring it like this. So that will be done using neural networks. How? We use something called as training and gradient descent. Okay. So what we will be doing is, we will be having many training points. So the neural network will be taught So now we will teach the neural network. Now if the age is greater than 18, he has to participate. If not, he cannot participate. So the neural, we will be showing examples and the neural network will learn on its own. So now this is called a supervised learning. Okay. So we will be, initially the line will be like this. So we will be giving some points. So X means true. So we will be giving points like this. So if the age is like this, it is true. So Y is of no consideration here, but this neural network is taking Y into account. So now it is doing a mistake. So now the neural network will give a positive value here and will give a negative value here. So all these points should be marked as positive, that they are marked as negative. So the neural network has made a mistake. So it will correct the mistake. So it will change the weights, it will change the coefficients of X, Y and that 1, and it will come up with a new line, something like this. So now that will be done using gradient descent. Okay, so now the error is minimized but it is not eliminated completely. So let's say now after lots of training, lots of weights getting changed, the neural network came up with something like this. So the neural network came up with something like this. We are having 3 here and we are having 18 here. So now all these points got classified correctly. All these values got classified as positive. But this is not the solution which we wanted. So what we'll be doing is we'll be teaching other things, like if the age is, let's have it as dash. Dash should be negative value. If the age is 16, 15, 14, 13 and all those things, it has to be negative. So now for this training points, the neural network is giving wrong solutions. So the neural network will once again train itself to achieve this line. Ultimately this line will be achieved. Similarly, the values of the coefficients of X, Y will be changed to achieve this solution. So we will be having our training points like this and like this. So it will draw a boundary between the correct and the wrong points. So that is what a neural network does, and it does it using gradient descent. Okay, but what if we have other kind of problems? Now these were all straight lines, X plus Y minus 80, sorry, X minus 18, Y minus 18 were all straight lines. This is a straight line and this was a straight line. But what if I want to take X and Y both into consideration? So the age should be greater than 18 and the BMI should be greater than 18. So what I have to achieve is this line. So it will be X and everything else will be minus. So this is 18, now this is 18. So this is what I should achieve. So using a single neuron, so these individual neurons cannot solve this problem. So what we will be doing is, we will be clubbing both these solutions together. Now this will be added with this, but before that we will be doing something called as activation. Let's see what an activation is. For activation we use something called as an activation function, and that function will return something like this. So now this is the output of the neuron. So now let the output of the neuron be something called as Z. So now Z, if Z is 0 or greater than 1, I mean greater than 0, it will return a 1 and otherwise it will return a 0. So now that is called as thresholding activation function. Okay, but okay, now first let's see about that. So now for age we have a neural network, age network, and this another network will be for body mass index. So now this is one bias and this is another bias. Okay, so now we have to club together both these functions. So this line and this line, so X minus 18 and Y minus 18 should be clubbed together to achieve this. So how we do that is, we pass this output and this output through an activation function and it will return us a value called as 1, 1. So let's visualize it properly. Okay. So the first solution was this. So by passing it through the activation function, we got 1, 0, and here we got 1 and we got 0 here. Okay. So now this region is 1 and this region is 0. This region is 1 and this region is 0. Now let's add together the outputs of these neurons. So what we'll be getting is, so now this is 18 and this is 18. So if the age was, if both the age and the body mass index is greater than 18, we will be having 1 plus 1, 2, and here this is 0 plus 1, it will give me 1, and this is 1 plus 0 and it will also give me 1, and this will give me 0. So I got something like this by clubbing this. It's like I had something like this and I had something like this, and I clubbed them together and added them. So I got something like this. Now if I have to do thresholding once again, now I have to pass this also through an activation function. Now the activation function, instead of it being something like 0, we will have it here, 2. So if the number is greater than 2, it will give me 1, otherwise it will give me 0. So now only this will be converted to 1 and the others will be converted to 0. So we got this region. So by using two linear functions and an activation function, we are able to achieve a non-linear solution. So that is called as deep learning. So instead of having one layer of neurons, we will be having more layer of neurons. Now I'll put it more clearly. So first I had 2 neurons and those neurons got added here, and that gave me a solution of yes or no. And for that I had 3 values, x, y. No, I'll have it like this. And I had a bias here and I had a bias here. I'll call it bias 1 and I'll call it bias 2. So all these will be implemented using matrix multiplication. So for matrix multiplication we need more processing power, and that's where graphic cards are used. Okay, so graphic cards are it's like they are best friend of neural networks. So neural networks will perform better in a graphics card, and that's where deep learning, that is the concept of neural networks. Okay, so by using gradient descent and by having more neurons, more layer of neurons, we are able to achieve many many solutions. Now we have something called as overfitting. Now let's say my training points were like this, x, 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 and all these things were all negative. Okay, so now a neural network has to achieve something like this. But what it will do is, if it is overfitted, it will come up with something like this. So this region will only be positive and the others will be negative. So it achieved 100% accuracy for our training data. So now these are all training data. So for training data we are able to achieve maximum accuracy, but that model was inaccurate. So to prevent overfitting, we have to feed more data. We have to feed more data. So that's why deep learning is on the rise only in this decade. So deep learning has been there for ever since 1960s, but only now we are having massive sets of data and massive processing power like GPUs, graphics cards, and that's why deep learning took pace after the 2012 year. Okay, so now let's see a small demo in our laptop, which you can also try from your own home. Actually, before going to that, I have something to explain. So we use something called as thresholding for our activation function, 1 and 0. So if it is greater than 0, it will be 1 and otherwise it will be 0. Okay, but this is not what we will be using in our deep learning. What we will be using is called a sigmoid. So instead of achieving a sharp 1 and a 0, we will be having values even in between 0 and 1. So if the output of the neuron was 0, it will give us a value 0.5. and if it is a very very huge value like infinity, it will give us 1, and if it is negative infinity, it will give us 0. How we do that is using sigmoid function. So 1 plus 1 by 1 plus e power minus z. We know that z is the output of the neuron, which is wx plus b. So now this wx plus b is z, and it will be passed through this activation function. And now if z is positive infinity, now e power minus infinity is 0. So 1 by 1 will give us 1. And if it is negative infinity, it will be the denominator will turn into infinity. So 1 by infinity will be 0. But if we are having 0 as our z value, e power minus 0 is 1. So 1 by 1 plus 1 will give us 0.5. So instead of achieving a sharp 1 or a sharp 0, we are achieving values between 1 and 0, and that will be useful for gradient descent. That's why we will be using sigmoid function, activation function. Now we also have another activation function called as rectified linear unit. Now that is also known as ReLU. So it will do something like this. So if it is greater than 0, that same number will be thrown out by the neural network. But if it is lesser than 0, it will give us 0. So this will be x and this will be 0. So now this will be x. Okay, now I will call this z and I will call this z. If z is greater than 0, z will be thrown back by the ReLU. But if z is lesser than or equal to, if lesser than 0, it will throw 0. So now that is ReLU activation function. And another one which can be used is tan h. So instead of giving plus 1 and 0, it will be giving plus 1 and minus 1, and also give values between plus 1 and minus 1. That is called as tan h, and this is called as ReLU. So now let's move on to the demo. Hello friends, welcome to the demo. And for that, let's go to Chrome browser because it's not working properly in Microsoft Edge. Okay, it's loading a bit. Okay, so let's type neural network playground, and here you have to go to this link, playground.tensorflow.org, and I'll give that link in the description below. Okay, so now what we are going to do is, let's take this data set. Okay, so now something consisting of training data is called as data set. So now this is one data set, and so now this is testing data. So then these new points are testing data, and the neural network will not train with this data. So it will be only be training with this data, and testing data is used to check whether the neural network has achieved proper accuracy. Okay, so now let's try out a small neural network with only one layer and one neuron. So let's try it out. Okay, so we achieved a solution like this for this neural network. Now this is a linear problem, and we achieved a linear solution. Now let's try it in another data set with the same structure. So as you can see now, the neural network is struggling. Okay, sorry. Okay, now so it is only able to come up with a linear solution. Now you can see that the activation function which we use here is tan h. Now let's try out sigmoid. It doesn't matter what activation function we use, we will only come up with a linear solution. So to obtain a non-linear solution, let's increase the number of neurons. So we are having two linear solutions, and it will be combined to give us a non-linear solution. Now let's try this out with the sigmoid activation function. Okay, to some extent this is a non-linear solution. Now we are having a kind of a curve. It's like a kind of a closed. Now this going beyond this region, we'll be having a oval shape, but this is not the Pakka solution, which this is not the proper solution which we need. Although this is able to give us a good accuracy, this is not the one which we want. Okay, now let's try it by increasing the number of neurons. Now let's try it out. Hmm. Although this is better than our previous solution, still this is not what we want. Okay, now let's just increase the number of layers instead of the neurons. Now let's add another layer with two more neurons in that layer, and now let's try it out. Okay, so we are getting something. Let's see what it is. Okay, now this is better than our previous solution, but still, is this it? Okay, so we are almost there. Now we are. It is giving a very small training loss. As you can see here, it is giving a perfect accuracy for the training data, but the testing data, you can see the test data here. Now for the test data, we are not able to achieve good accuracy because here there is a point here, there is a point here and all. Okay, so what we'll be doing is we have to increase the training data, and let's try out the same neural network. Mm. So the loss is decreasing here, as you can see here. So we are performing gradient descent here or something like that. Still, this is not what we want, but this is improving as time passes. Okay, so we almost got what we wanted. So if the non-linearity of the training data set is very much high, we have to increase the number of neurons and the layer because it won't be enough to get the perfect solution. Okay, so we have achieved a superb model. The test loss is very small. Okay, so what we did is we just increased the training data set and the number of layers. Okay, now let's try out another training data set, and let's try out a ReLU activation function. Wow, so that was super fast. So the ReLU data set, I mean the ReLU activation function is better than our sigmoid activation function because ReLU is almost similar to what is happening inside our brain. Actually, deep learning and neural networks are based on what our brain does. It is loosely based on how our brain works. Okay, now let's try out our final data set, a spiral data set. Now this is the most difficult data set. Now we would be having many layers and many neurons. Now let's try it out with this. The neural network is struggling to find a solution. Okay, now let's just increase the neurons. Let's try it out. Although it is struggling, it is better than what we achieved previously. Okay, now I'll resume the video once after it has been done. So hello friends, now this is what happened after the training got over. Now still the training is taking place, but I'll pause it. So we are able to achieve this with this neural network. Now I'll come up with an even better neural network. Hello friends, now this is the result of the another training process, and I was able to achieve this in just 500 epochs compared to the previous training, and I have increased the number of layers and the neurons. Okay, so now I hope you understood the concept of deep learning pretty well in this video. If you have any doubts, leave a comment below and I will clear it for you, and you can even try out this TensorFlow playground, and you can find the link below. And don't forget that Dexbot is taking place on March 8 and 9, where I will be taking a workshop on image processing. So if you are interested, do visit the link given below. Thank you.